Welcome to students of classes 7 and 8. I had placed a YouTube video quite a few days back on elements, compounds and mixtures. Today I am going to explain to you or discuss with you the separation technique of mixtures. Okay, we are going to discuss the different techniques of mixture. Now first of all let me tell you that mixtures are of two types, heterogeneous mixture and homogeneous mixture. Now when it is heterogeneous mixture, what is actually we mean by heterogeneous mixture is that where the components present in the mixture are not uniformly distributed. Okay, you can see the components separately, that is said to be heterogeneous mixture. And where the components and the composition remains uniform throughout the mixture, that is a homogeneous mixture. I'll just give you two examples. For homogeneous mixture, the common daily life example what we have is that when we make sugar solution or salt solution, when you are adding salt to the water and you are dissolving, you are finding salt is dissolving in water and you cannot see the salt particles separately, or sugar solution, same thing, you cannot see the sugar particles separately. So this is an example of homogeneous mixture. And when it is heterogeneous mixture, suppose you take sand and stone, small pieces of stone. So that will be heterogeneous mixture where you can see the pieces of stone separately, where you can see the sand particles separately. So this comes under heterogeneous mixture. So first of all, we separate mixtures into two categories. One is that homogeneous mixture, the other one is the heterogeneous mixture. Now I'll come to the different separation technique of mixtures. Now we'll start with the different separation techniques. First of all, I'll start with solid-solid mixture. Now first of all, the most common one which we use at home is hand picking. You will be finding sometimes rice, we say, it's mixed with small stones and all. So there we apply the process of hand picking, because you find the stone particles are of a different color, shape and size, and the rice grains are of a different shape, so you can separate them. So one of the method we apply is the hand picking method. Next we have magnetic separation. Second method we come to magnetic separation. Now magnetic separation itself means that there is a presence of a magnetic substance. Now it's mainly used where iron particles are present with any other substances. If iron particles are present with any other substance, we use a magnet to remove the iron particles. So that is the theory of magnetic separation. We separate iron from sand, iron and sulfur. So wherever iron particles will be there, we use magnetic separation. Next we come to gravitational method. Now gravitational method means, suppose you are given sand and chalk powder or sawdust. So how to separate them? So in that case we add water. Now here gravitational means method what? When you are adding water, the chalk powder or the sawdust is lighter, it floats on water. And the sand particles which are heavier, that settles at the bottom. So in that case what you do, then you decant it. Decant it means pouring it. So when you are pouring it, you will be finding the chalk powder or the sawdust which you are using, which is on the top layer, that is getting separated from the sand. After that you can filter and all. If you find any amount of water is present, yes, there will be water present. So in that case you filter it and you can separate the chalk and the sawdust, whatever you are taking. Next I'll come to sublimation method. Now sublimation method means one of the component in that mixture, these are all heterogeneous mixture I am talking about, solid-solid heterogeneous mixture. Suppose there is a sublimable substance present and along with that any other substance is present. I'll take a very common example. You are given ammonium chloride. Ammonium chloride is a sublimable solid. Iodine is there, camphor is there. So with ammonium chloride, if you are given sodium chloride, both are white solids. So how you can separate them? So we take the mixture in a test tube or in a watch glass and then you put an inverted funnel over it and you heat it, you find ammonium chloride or the sublimable solid which is there, that will sublime. Once it sublimes means it changes to vapor, and the vapor then solidifies or cools on the upper part of the funnel, or if it is your test tube, there it forms a sublimate. So ammonium chloride can be separated from sodium chloride. If you are given iodine with some other substance, we can use the process of sublimation. Next we come to another very important method which is called solvent extraction. Now what is the solvent extraction? Suppose solvent extraction means you will be given two solids. They are heterogeneous solid-solid mixture. One of the component of that mixture is soluble in a particular solvent, the other is not. Let me give you an example. You have been given calcium carbonate or chalk and sodium chloride, and you are told to separate these two components. So what I am going to do, or what is the process to be applied, is that we add water. Why I am adding water is that calcium carbonate or chalk, what is given, that is insoluble in water, and sodium chloride is soluble in water. So first we add the water and then we stir it with a glass rod. Sodium chloride will dissolve, calcium carbonate will not dissolve. Then I will filter it. When I am filtering the solution, in that case what is happening, in the filter paper that calcium carbonate collects as a residue and the sodium chloride solution collects as a filtrate. So calcium carbonate is already separated. Now you want the sodium chloride solution back. So in that case what is to be done? The sodium chloride solution has to be evaporated. Water will evaporate and you will get back the particles of sodium chloride. So this is called solvent extraction method. Here we are using the water as the solvent. Suppose you are given carbon and sulfur, charcoal and sulfur. Then how to separate? In that case we have to add the particular solvent carbon disulfide. When I am adding carbon disulfide, sulfur is soluble in carbon disulfide. Charcoal or carbon, what you have been given, that is not soluble. So again the next process is filtration. In the filter paper you will get the charcoal as a residue and sulfur will be dissolved in carbon disulfide, which will be collected as a filtrate. Then you evaporate and you get back the sulfur. So these are the techniques of solid-solid heterogeneous mixture. Now I will come to solid-liquid homogeneous and heterogeneous mixture. Now first let me come to solid-liquid heterogeneous mixture. Suppose I will start with sand and water. So mud and water, sand and water, we apply the technique of sedimentation and decantation. So when we are taking sand and water, we find sand settling at the bottom, which is called the sediment, and water is on top, which is called the supernatant liquid, and that is separated from sand by the process of decantation. Next method comes as filtration. Take chalk powder and water, or normal talcum powder and water, or sawdust and water. So it's a lighter one, it is not dissolving, it's floating there. Now you filter. When you are filtering, in the filter paper you get the residue, chalk powder, or if you have been given sawdust, whatever it is, that collects as the residue and water collects as the filtrate. So these two methods are for solid liquid heterogeneous mixture. Next, coming to solid liquid homogeneous mixture, salt solution. The common example, salt solution, you can apply the process of evaporation or distillation. If it is evaporation, what is happening? Water is evaporating, you are getting the salt. And if it is distillation, what is the advantage of distillation is that there you get back the solvent as well as the solid. That means salt solution is distilled, salt will be remaining in the distillation flask and water will evaporate. It will pass through a Liebig's condenser. Condenser means its function is to do the condensation of water vapor. So when water vapor condenses, it will change to a liquid that will be collected as a distillate. So advantage of distillation is that we get back the solute as well as the solvent. That is, the solid you get back and also you get back the liquid. Here when I am taking salt solution, salt is the solute and water is the solvent. So this is for solid liquid homogeneous mixture. Next I will come to liquid-liquid heterogeneous mixture and liquid-liquid homogeneous mixture. Now liquid-liquid heterogeneous mixture is separated, the common one is by a separating funnel. Now common examples are oil and water. Now a separating funnel has a tap or a knob at the bottom part and there is a opener, there is a lid type which you open and you pour the oil and water in it. Now oil has a lower density than water. Oil is floating on water. Water is at the bottom part, oil is on the upper part. Now you open the knob or the tap at the bottom. When you open it, the water which is at the lower part, because its density is more, it is flowing down, it is collected in another beaker or a container. After all the water level goes down, only oil remains in the separating funnel, we close the knob. So that is how oil and water gets separated. Next comes liquid-liquid homogeneous mixture, that is, in that case we apply the process of fractional distillation. Now fractional distillation process says that when two or more liquids are miscible liquids, now oil and water comes under the category of immiscible liquid, and this one, when I am telling miscible liquids means here alcohol and water, they mix with each other. That means liquids, when they mix with each other and you cannot differentiate which one is which type of liquid, they are called miscible liquid mixture. So in fractional distillation we apply, this fractional distillation is applied to separate the components of miscible liquid mixture. Suppose alcohol and water, we separate by fractional distillation based on the difference of the boiling point. I'll come to this part here. We have been given alcohol and water. Water boiling point is 100 degrees centigrade and alcohol boiling point is 78. So when we are applying the process of this fractional distillation, alcohol reaches its boiling point faster, means 78 degree. When it reaches at 78 degree, it will change to vapor. You have to condense the vapors and the alcohol vapors will later condense to form the alcohol liquid. So what remains in the container where you are doing the fractional distillation? Water. Next we separate them. In this way we can separate more than two components. But what is the criteria for fractional distillation is that the difference of the boiling point between two liquids should be minimum 20 to 30 degrees centigrade. It should not be 5 degree or 60. In that case, it is very much difficult to manage the process. So, minimum 20 to 30 degree difference should be maintained to separate miscible liquids, and that is done by the process of fractional distillation. So, I have discussed more or less the common methods which are used in separation techniques of mixture. Hope you will enjoy what I have said. Let me come up with some more separation techniques I will discuss with you later. Thank you.